Hello, welcome to how to solve this exponential equation. X to the power square root of y minus z is equal to 20. This x to the power square root of y, x to the power square root of y has power 1 here, minus z is equal to 20, and this power 1 is equal to 1 over 2 times 2. So we replace this 1 with this 1 over 2 times 2. X to the power square root of y whole to the power, we replace this 1 with this 1 over 2 times 2. 1 over 2 times 2 minus z is equal to 20. Next, according to the property of exponents, a to the power m whole to the power n is equal to a to the power m times n. We multiply this power square root of y with this 1 over 2. X to the power square root of y times 1 over 2 square root of y over 2 whole to the power this power 2 minus, and we can write this z as square root of z square is equal to 20. Next, we suppose that let x to the power square root of y over 2 is equal to a and square root of z is equal to b, and we substitute these values a and b in this equation. Then this equation becomes a square minus b square is equal to 20. Next, we factorize both sides of this equation. According to algebraic identity, a square minus b square is equal to a plus b times a minus b is equal to, and this 20 can be factorized as 1 times 20, 2 times 10, 4 times 5, 5 times 4, 10 times 2, and 20 times 1. Now you can see that a square minus b square is equal to a positive number 20. It means a square is greater than b square. A square is greater than b square and a is greater than b. So a plus b will be greater than a minus b, and from these factor pairs we select only those pairs where first factor is greater than the second factor. Like this 5 times 4, here this 5 is greater than this 4, and this 10 times 2, here this 10 is greater than this 2, and this 20 times 1, where this 20 is greater than this one. Now we notice that here we have two variables a and b, and if we add these two factors 5 and 4 and divide it by 2, 5 plus 4 divided by 2 is equal to 9 divided by 2. 9 divided by 2 is not an integer, so no integer solutions can be found from this pair 5 times 4, so we reject this one. And if we add these two factors 20 and 1 and divide it by 2, 20 plus 1 divided by 2 is equal to 21 over 2. This number 21 over 2 is not an integer, so no integer solutions can be found from this factor pair 20 times 1, so we reject this also. So the only pair for which we can find integer solutions is this factor pair 10 times 2. So we factorize this 20 as 10 times 2, 10 times 2, and we write this greater factor a plus b equal to this greater factor 10, and we write this smaller factor a minus b equal to this smaller factor 2. A plus b is equal to 10 and a minus b is equal to 2, and we add these two equations, 1a plus 1a, 2a, and this positive b will be cancelled with this negative b, is equal to 10 plus 2, 12, and we divide both sides by 2. This 2 will be cancelled with this 2, and a is equal to 12 divided by 2, 6. Now we put this value of a 6 in this equation to find the value of b. The value of a 6 plus b is equal to 10, and we move this 6 to the right side. B is equal to 10 minus 6, and b is equal to 4. So the value of a is 6 and the value of b is 4. Now recall that we have supposed that x to the power square root of y over 2 is equal to a and square root of z is equal to b. We have supposed that x to the power square root of y over 2 is equal to a and square root of z is equal to b. In this equation we put the value of b 4. Square root of z is equal to value of b 4, and we take square of both sides. This square will be cancelled with this square root, and z is equal to square of 4 is 16. Now in this equation we put the value of a 6. X to the power square root of y over 2 is equal to the value of a is 6, and we take a square of both sides. This square will be cancelled with this 2, and here left x to the power square root of y is equal to 6 square. Now we compare the base with base and the exponent with exponent. So from here x is equal to 6 and square root of y is equal to 2. Next, to find the value of y, we take square of both sides. This square will be cancelled with this square root, and y is equal to square of 2 is 4. So the value of x is 6, value of y is 4, and value of z is equal to 16. Now to verify these values of x, y and z, we put these values in the original equation. The original equation is x to the power square root of y minus z is equal to 20. In this equation we put the value of x 6, value of y 4, and value of z 16. Value of x is 6 to the power square root of value of y 4 minus value of z is 16 is equal to 20. 6 to the power square root of 4 is 2 minus 16 is equal to 20. 6 square is 30 minus 16 is equal to 20, and 36 minus 16 is 20 is equal to 20. From here you can see that left hand side is equal to the right hand side. So it is proved that the values of x 6 is correct, and value of y 4 is correct, and value of z 16 is correct.